Awesome, thank you. So hi, my name is Paweł. By day, I'm the CTO at Visuality. And today I'm gonna talk to you about what brings me joy and what keeps me going after being for more than 20 years a software developer, what keeps me going every day, what gives me the strength to get up and to still be in the business. And that's gonna be the creativity, especially the one that you can express using AI and LLMs. However, before we get there, I would like to just briefly touch on the state of the web as for 2025. How did we get here from the very first website that was published not that long ago, in 1991? It looked like this, mostly due to the capabilities of monitors back then. It was just dark and green. But it used text, headings, and links. You can still see the very same page on your modern monitor if you go to this page. It's still hosted for the future generations of programmers. And if you open that, if you look very deeply, you can see something that resembles the modern HTML. And it has text, it has links, and it has headings. So it's pretty much the same as we have. And how I look at this is that people 30 years ago, they got a new medium. They got internet, the web. But they didn't really know how to use it. So they've taken what they already knew, a way of printing text with some headings, and not images back then, but very shortly after. So they copied an idea of a newspaper, and they've put that as a web, as this new medium. And frankly, nothing has changed over the last 34 years. How come? Well, it was some kind of progress. We got images, sound, video over the years. Finally, in 2009, we got some decent JavaScript with ES5, so we got some interactivity. And the last progress that I found was WebXR. Has anyone used it? It's the fourth time I'm telling this story, and never anyone. So this is how it was important, but not the majority of us. Yes, exactly. We can talk about it later. So as I look at this, now we have images, we have videos, we have sound. So basically, we are no longer putting a simple newspaper, paperback newspaper into web. Now we are putting magazines. And we think we did something special. Well, we didn't. Nothing has changed within this progress over the 30 years. At some point, I ran across two quotes by Steve Jobs from the same interview. He described how it has taken 20 years for the radio to find its own way. Because the first TV shows, the TV to find its own way, because the first TV shows were actually radio shows, just filmed. People were sitting behind desks, it was filmed, and others could watch that on the television. And that was called the television. It was something new, something great, but it took them like 20 years to find a different format, something that would bring the benefits of vision and distinct it from radio. Of course, web wasn't that stagnant, and we already had 30 years, not 20. So a lot of software was pushed to the web, like e-commerce, like e-learning, e-medicine, you name it. However, I'm not talking about this breakthrough. Let's have another story. So a phone was invented in mid-19th century, right? And for the next 150 years or so, there was progress. So the phones were easier to install. easier to use, more people got them, but we were still talking just using this phone in our hands. Eventually, we lost a cable, but it was still progress. It's just a different form of transport for this signal. And introducing Snake to Nokia wasn't this breakthrough either. It was still a phone, just with a game. What I'm talking about is this, a spark of brilliance, not by Apple, for no means, but Apple did it right, because Apple added marketing. And when iPhone came, it really started. So this spark of brilliance, this change of the game, actually made us use phones in a completely different way. So finally, if we look back at the very beginning, what we got was not a phone, but a way to transpose information between people in different parts of the world. And we used that in a very different way, and now we have smartphones. So I was really looking for something like that in web. However, as it wasn't coming, I tried my different approaches to being creative through Ruby on Rails. At some point, I was really into domain-driven design, which I already discussed today with one of you. So I've written like 8 articles or so. I've done presentations, webinars, and so on. I had tons of discussions. That was kind of creative for me because DDD is not really something that really fits in Ruby on Rails on a daily basis. But it was so technical, so I went back to the thing that I enjoy the most, and that's making games. At some point, I was asked to write a game for Euroco conference in Vilnius in 2023. And I figured, yes, so let's use Ruby on Rails for backend and for frontend. So I made Tetris. It was a game that people were able to, they could play it, and whoever scored the most points got a ticket to Euroco. After that, I created Frogger. So it's a real-life multiplayer game with nothing but Ruby on Rails with no additional gems in tech stack. And it's real-time multiplayer. I can talk to you about that in a second as well. However, as I was talking about those, it was really hard because I was using Keynote and I was showing my games. So at some point, I ended up with playing Tetris behind me with my left hand, trying to show, hey, I can score some points. Of course, I couldn't that way. So I created another thing in Rails, and it was presentation platform. So that I can showcase my work, not switching between a presentation platform and Ruby on Rails. So what you are looking at, actually, it's Ruby on Rails. This is a Ruby on Rails application deployed to DigitalOcean using Camel. It uses Active Record, Turbo, Stimulus, Tailwind, and so on. And even though it's a Ruby on Rails presentation, so it's actually a web page, I can still use the clicker to go back and forth with slides. And just to show you that it uses Tailwind and Stimulus, I can maybe do something like this. Yeah, this is the extent of my frontend. However, it was never enough. Again, it's technical. It's the same it's the same thing. It's just progress. It's not revolution. It was never enough until large language models came. I believe I don't have to explain what a large language model is. At this point, this presentation was firstly done like several months ago. By now, probably all of you have used GPT, Gemini, Llama, DeepSeek, or whatever. Those are models, machine learning models. They can kind of understand, or at least process, and produce human-like text. And we usually interact with them by prompting, so by sending a message and receiving a message. So basically like API-driven communication. However, Ruby on Rails is full stack. And I want to use LLMs like a full stack. So let's do that. Let's start with voice control. But of course, it will be LLM-driven and made fun. So allow me to show you. At our company, at Visuality, we have a position that is very rarely filled, and it's called Chief Happiness Officer. It's filled by a dog, a curly dog named Ruby. and she serves as my assistant sometimes, but I couldn't bring Ruby today because, well, first of all, it's not my dog, it's Mariusz's, and it's kind of a long trip. So I brought my other assistant. He's called Jem, and allow me to bring him to you. Hey, Jem, can you please come to us? There is a bit of delay because we have over-the-wire communication. And you know what? Let me try again, because maybe it didn't hear. Hey, Jem, come to us, please. No. Oh, here it is. This is Jem. He reacts to my voice commands if he's not lazy, but he can do a few tricks. But first of all, let him stand in a better place. Hey, Jem, go to the left, please. It's not magic, it's not prescripted. Whenever you see a red bar at the top, it means I'm recording my voice and expressing the command. I will show you how it works in just a second, but first of all, he really tried to learn some new tricks. He's not good at jumping, but let's try. Hey, Jem, can you jump, please? Let's see if he can do it. Almost? Not so much. All right, and the last trick that we really tried. Hey, Jem, can you please sniff around? I don't have to say please all the time, but it's just better manners. Yeah, so yes. So this is Jem, and I just want to remind you that what you're looking at is a Ruby on Rails application. So whatever you see today can be implemented right away into your production, maybe, but for sure your side projects. Let me show you how Jem works. So how to implement voice control? There is a million ways to do that. Today I'm showing you mine, and this one embraces Ruby on Rails possibilities. So first of all, we're gonna record audio, we're gonna send it to server, we're gonna convert the recorded audio to text. Then we're gonna figure out what was the command, and I promise you, no regex at all. Then, after we know what's the command, we're gonna broadcast it back to front end, so to our presentation, and we're gonna use JavaScript to perform an action. So we start with recording, and for that we need JavaScript. Guys, again, Ruby on Rails is full stack. Yes, I know we love Ruby and we prefer Ruby, but to interact with a user, you need to speak in the language of a browser. So in JavaScript, this is actually like almost everything that we need. There is a media recorder library that is available in all the browsers that you guys use. So just take it, you instantiate a media recorder object, you start, you finish, and whenever you finish, data is available, you have a binding for that, and so what we call send audio function. This is send audio, it just takes a blob, so this blob is actually your recorded web media file, in fact. So what we do, we construct a request to a server, we send it as a post, we can even add a CSRF token just to be safe, and we send it where? Well, to Ruby on Rails. We finish with JavaScript. Now we have a totally cruddish server, controller. So we have a create, we create a new active record, which has one file attached, and we attached our audio. And that's it. We record it, and we send it to server with just a few lines of code. But this was Ruby on Rails, and this was JavaScript. Now it's time for LLMs. I'm going to be using Ruby OpenAI Gem. It's quite low level. I hope most of you have heard about it by now. If you would like to go deeper, you would actually have to use probably Faraday or whatever, like direct API calls. OpenAI is just the level of abstraction that I prefer. And throughout the presentation, I'm going to use this constant of OpenAI client, which is just an instantiated client of OpenAI. All right. So you've seen that I've created an audio object, active record object. It has one file attached, and the next line, the third line, is something that I don't normally use, and it's a callback, especially after create commit one. I don't often use callbacks, but for the presentation's sake, this allows the entire procedure to be seen in one slide. So after an audio is created that you've just seen in the previous slide, I want to transcribe it, so convert audio to text. For that, all I need is one simple call to an LLM. I'm using Whisper one model. If you've ever done something with transforming audio using LLM, you've probably heard about Whisper one. It's a beast, actually. It's a model that understands like 100 languages or so, can convert your audio between most of those, or like at least 50. In here, I'm using it a very, actually I'm calling it to translate, but it also has a transcribe method, so you can just use it directly from OpenAI as transcribe. And I just put the file directly from Active Record. So what I get in return is actually a transcription. So the answer is a string like, hey Gem, go to the right. Now we have to figure out what does it mean. If I take this string, hey Gem, go to the right, and send it to LLM, like a prompt, this is a real answer from GPT-4o probably. So it says, okay, it seems that you want to go right, but what the heck? What do you really want from me? I can't go right. However, many modern LLMs have additional ability, and that's function calling or tool calling. The name changes more frequently that I give this talk. So for the sake of this presentation, I'm going to call those tools. In addition to the prompt, I can also provide tools to an LLM. So I can say, hey Gem, go to the right as prompt, but I also can say, hey LLM, here are 2 additional tools. If you feel like using them, tell me. So if an LLM sees, hey Gem, go to the right, and 2 tools, move left, move right, it would answer saying, move right. It would say, it is a tool call, move right. If I say, hey Gem, go to the left, it would say, move left. However, if I ask what's the capital of Poland, it would still answer it's Warsaw, because it still operates in this broad context. It just has additional tools to do stuff that it wouldn't be able to otherwise. But the tools are much more complex because we can provide parameters. It can be 1 parameter, it can be 5. All we need to do is provide a tool, describe how it works, or what for it is used, and explain what the parameters are. So for example, in here, move x, when x is a location between -3 and 3. If I say Gem, stand in the center, it would call a tool move with param 0, because it means center. If I say move right, it would be 3 or anything in between. All right. One thing, this entire presentation, this entire Ruby on Rails application is open sourced and will be linked at the very end of this presentation, all apart from the 3D model of Gem because it's not open sourced. All right, so this is how tools work, and let's put that in Ruby, and it's so simple. Because previously, normally we would just ask OpenAI with a chat, for example, method. In here, I'm using GPT-4o, and I'm sending a prompt, hey Gem, go to the right. But I also can provide additional tools. And this is an elaborate way of saying this is a function of a name move to, it's a description, okay, you use it to move the dog, and it has the x parameter. I can provide more function, for example, jump, for example, sniff, and so on and so forth. So whenever OpenAI client, so an LLM says that I want to do an action, in here, go to the right, it answers with such a hash, which says, well, it's a tool call of a function move to x3. And this is all it is. I send hey Gem to the right, send all the available tools, and LLM responses use this one. With that, I can put that into my audio, again, probably not for production usage. So I have after create commit, transcribe, and parse. After this, I have transcription, and I have parsed commands and params of those commands saved within active record. With that, we've successfully converted audio to text and figured out what the command is. Now we have to go back to front end and say back, hey, the server has figured out what to do, and here is what it is. We are going back and we are adding one last one, I promise, element of this callback iteration. So we transcribed, we parsed, and now we broadcast. How many of you, if you could tell, by a raise of hand, use Hotwire in production or in your pet projects? Whoa. Usually, thank you. Usually it's like 2 people in a crowd of 50. But that's great, so you're gonna at least know what I'm talking about. So when I broadcast, I put it over the wire, and I want to broadcast this very object. Let me show you. So whenever I have already parsed audio, I broadcast this audio element to audio's stream. For that to be received by a browser, all I have to do is have this turbo stream from audio's call, so that the browser establishes a connection with the server. And I have audio's empty div, so I have a container where I want to put my audios. So whenever an audio element record is broadcasted, it's going to be intercepted by frontend, and it's going to be rendered inside of this audio container. And this is when I start to cheat. Because you saw that I was speaking and the gem was moving, but nothing was really appearing on the screen. Because what I'm rendering inside of this div are actually some more empty divs. Those divs have 2 things. First of all, they have data controller set to audio. This is the definition of a stimulus controller, stimulus JavaScript controller, that is supposed to be automatically launched. And this controller, the JavaScript controller, will be given those additional values. So whenever I render this inside of this audio div, I automatically launch a stimulus controller. This controller is given the command name and the command params. All I need is an ugly if. So if the command is move to, call some JavaScript function. This actually moves the dog to the parameter x. So this is how it's done, from front end to back end and back to the front end. So we've done it, we recorded, we sent, we converted, and so on. However, it wouldn't be enough just to steer a dog, because what for? Well, it's fun, but it has so many other consequences or use cases. For example, those letters are intentionally small, because now with voice control, I can, for example, say, make the letters bigger, please. And with the same procedure, it can detect that I wanted it to be bigger. I said, make the letters bigger, right? So let's tell, make the font larger, please. And it would also detect. In fact, it would detect the same tool, because it doesn't matter how I say it. It's not the phrasing that is important. The important thing is the merit behind what I'm saying. This is the power of the LLM. It can really understand to some extent. I know it doesn't, but still, it can process it and figure out what I meant. This is one idea. The second one is this. This is something that I really would like to have everywhere. Enable dark mode. It would be so much easier just to tell it to a page, not find the small button. But it's still, these 2 things are still a toy in comparison to this. I don't know how you guys, but when I open an e-store, I feel like I have to be an expert. I have to know what to put in all the filters on the left or on the top. If it comes to a laptop, for example, me buying a laptop for my son, that's fine-ish. But when I go to a hardware store, for example, I don't have a clue what to buy to paint this wall, for example. And I would so much like the store to help me, not to make me learn about all of that. So let's see if a tool call can help us with that. Imagine a person, a non-technical person, coming to the store and saying something like this. Hey, I want to buy a laptop for my son. He's gonna make his homework and play video games. I don't know what to buy. I don't want to spend more than 1,000. But because of his homework, I think he's gonna need the biggest screen possible, right? Can you please help me? And let's send that to an LLM. Thanks to tool calling and the ability to figure out what's the actual need behind what somebody has said, we can allow the LLM to select the filters from what I've said, and it can select more if the filters are sometimes somehow understood from what the person has said. And the LLM can even provide some reasoning why this or that, can even answer with, hey, maybe you want addition, how about this, how about that. So we can have this virtual assistant without chat. The voice control is more than enough. In this case, it's up to the designer of the page to understand what's in the filters. And it's up for designer of the page to put it into an LLM, this information of what's in the filters, so that an LLM can help your customer. And I could stop here because for me it was already creative and fun, but it wouldn't be enough. I would really love to share one other concept with you, and that's image recognition, and of course done with LLMs as well. I don't know if you guys do selfies. I sometimes do. So let's take a selfie with Ruby on Rails. Of course, not Ruby on Rails. We do that with JavaScript. This is the same library. I'm not showing the code again. This is the same library that I used for sound. I just enabled video in that. And I have access to all the cameras. Let's take a photo. All right. And let's go further. 2, 1. All right. When I first created this presentation, I was really thinking about how to make it in a way that people wouldn't think that I prescripted that. That's why I made it a bit more fun. You remember that this is actually a page deployed to DigitalOcean and using Kamal and so on. So I can also access it from my phone, and I can take some pictures. Again, sending to server, Hotwire. Those of you who work with Hotwire know that this is quite basic. Does anyone else want to be in the photo? Can I take your photo, sir? Because you have a very distinctive shirt, at least between you and Jarek. When I take, just to make it harder. All right. So we have at least four images. Thank you. Now I'm still going to use voice control because again it's more fun, and I'm going to show you that. Thank you, Nick. That you can ask an LLM what's in an image. Find me an image of a computer. A laptop? I think it should be smart enough. All right. From what I've said, it detected that I want to find a computer, and it has found me an image that resembles the computer the most. how it works. I won't bore you with all the details because I want to leave at least some time for Chris to do his presentation, but still allow me to talk at least for a few minutes. So first of all, what's in this image? This is the question that we can ask to an LLM. We again use OpenAI client. In here I'm using GPT-4o mini because it's just cheaper than 4o. I'm sending a message, in fact, an array of messages. So the first one says, what's in this image? And the second is the image URL or base64 encoded version of an image. I prefer this one because otherwise I would have to expose this image in some way over the internet, which is just more work in general to care for the URL. In here, I can just base64 encode this image and send to the LLM. In return, I get an elaborate string. I can ask for something different. I can ask, hey, does this image contain X, for example? But in here, I just want a description. In here, if I send something like an image of a puppy chewing on a shoe, I would get something like this image, and I have this. Yeah. So I have like the image shows a curly-coated puppy, possibly poodle, and so on and so forth. This. Sorry. Yeah. He'll be back. So I get this is like a real life response from an LLM for this image. So we can use this image recognition in different ways, and we can use that in production as well. So you can, for example, validate contents of uploaded images to check whether that's work safe, for example. You can process security cameras. You can have like camera feed, and there are companies that do that. Maybe not in Rails, but still. You can process the camera footage and probe every like half a minute or so, or every 5 seconds, and ask, hey, is anyone stealing from me? And it actually would tell you. Or my favorite use case, you can allow only smiling profile pictures. And this is actually something that you should implement in production in your pages. So let's take those 3 last images that I've taken. And I'm going to briefly tell you how it comes to be that this LLM can actually find the most similar image. I know it's been quite long, 3 minutes, maybe 5. That's all I'm asking. And the most crucial piece of data is any piece of information, string, image, sound, unstructured, structured data, whatever. Every piece of information can be converted to an array of numbers. This array of numbers expresses all the meanings which an LLM understands about this information. So for example, if I take the descriptions of those images, I can embed them into this array of numbers. Those arrays of numbers are treated as vectors, and such vectors are called embeddings. So if we take these images, we can describe them, and let's take every such description and convert into an array of numbers. Let's embed it. How? Of course, we ask an LLM. Probably not Chat4o, no GPT-4o. There are targeted models for embeddings. So, of course, you can ask any model, but this would be more accurate. So, this model in particular would answer with 3,000 dimensions vector. And each of those values represent some underlying data, like how much in this picture is about dogs, giraffes, about work, about theft, about whatever. Every aspect of the realm, of the world the LLM understands is put within those. So let's switch to some more fun images. Those are I stolen those from Sora because I really like them. And I described them and I embedded the descriptions. And now a query comes, a search query. Find me an image of a bunny. I have embeddings, I have those vectors of all the images. So what I do, I embed this question, an image of a bunny. And I'm given this vector. Now, have any of you ever said that math's not really helpful in life and you don't really need it? This is the one moment in life that you should have paid attention in math. Because to find the image that's most similar to an image of a bunny is the same task of finding the vector that is closest to this vector. Because vectors that are closest to each other represent information that is most similar. So this vector, out of these three, is closest to this. And therefore, we found our bunny. This technique is called vector search. So we don't look for strings. We don't look for explicit information. We look for vectors that are similar to what we are looking for. So you can kind of forget about your Elasticsearch, for example. Well, nowadays Elasticsearch can use vector search as well. But this is a different approach to searching. You can search anything out of anything as long as you can embed it. And it's just a start. What I've described are two use cases, image recognition and voice control. You can go to a page like Hugging Face, where you will find endless models that can do more than you can imagine. At least in my case, it's so. There's so many things that you can do in your applications. Please never do another to-do list, or at least vibe code it. So I want to close on a quote from DHH from Toronto last year. He said, "It's more fun to be competent." And it is. However, for me, it's even more fun to be creative. Thank you. If you have any questions, we can do it now, or I'm all yours later on.
I had a question about the tools.
Mm-hmm. Please go ahead.
So with every query, you have to send all the tools as well.
Allow me to repeat so that it's saved in the recording. So the question is whether you have to send all the tools with every call to an LLM. Yes and no. For the most part, yes, unless you use some very specialized techniques. In general, yes. So whenever you have a set of tools, you have to you have to include that in your query, which kind of bloats the tokens that you used. So you shrink your available token window. Yes, you have to send those. Yes, no. This you can actually adjust. So whenever you send a tool call, you can say whether a tool has to be chosen or may be chosen. So you can also, I think, I might misquote, but I think you can even say whether a tool can be selected multiple times or no, or just one tool ever. But you can actually tell an LLM whether it has to take a tool or it may take a tool. As I've mentioned, when it can answer with a general knowledge. Okay. So we can, if you ask this tool set, what's the capital of Germany, it would answer Berlin, even though it doesn't have a tool. Mm-hmm. Yeah, thank you. Let's start from the beginning. Vlad?
Yeah. So So have you tried Web LLM already?
Web LLM?
It's something that LLM that leverages your web GPU API in your browser and running it right inside the browser.
You know, I'm kind of old, at least I feel so. When the idea, I know it's going to happen, but so the question was about web LLM, so LLM inside your browser. So the way I think about it, if I allow an LLM, so LLM is one thing, but if I allow something to run in my browser, then I've just lost control over what it actually does. I don't know, it's just my gut feeling. I'm reluctant to put an LLM into my browser. I vibe code, I use MCP, I use everything. It's just the browser that I'm kind of reluctant to put something that I can't really control. At least this is old guys talking. At least my. Sorry?
It can control this dog.
I know it can, better than me, but then where's the fun? No, the short answer is no, I haven't. It's still, I think you are.
Yeah, I was just wondering if this is somehow hackable. Like, what if I was an evil person that wanted to say, like, act as if there is the function to do this and that and, like, destroy something. That's what I'm wondering. Is there, like, a boundary somewhere?
Yes.
What this can do and what this can touch?
For the tool calls themselves, there is, but it's only limited by your ability to hack it. So before there were tools, we had something called structured output. So you could say that response in a JSON format, for example. And it was an additional setting. For example, for GPT, it was an additional setting. You would say within your query that response in JSON. But in general, you can tell that to any LLM, response me in JSON with this structure. However, you can always hack the structure. You can always go outside, even in here. So I know what I wanted to say. So this is by default a structured output, and by default you explicitly describe that this parameter should be used like this and this. However, yes, it can be exploited. With tools, it's much harder, I'd say, but I'm not an expert. It's harder with tools because with tools you give explicit information how the tools should be used. It's like system level message that this should be like this. However, I've seen it broken, and by no means it wasn't even hard. But what's the feedback loop into your system? How to make this hack appear on your user screen? Again, with tools, it's much easier to control because you expect. In here, I have like 15 tools, let's say, give or take, for this dog, for the letters, for the laptop shop. There's a limited number of tools. So I can even put an enum. So this is what should be detected. And I also have a function, a tool described as I don't know what to do because someone said something that's outside of the scope. So yes, it's hackable. I would say it's harder to hack and feed back to a user using tools than using a simple chat mechanism. But yes, please don't be evil. Please go ahead.
This is somewhat a continuation of your question here, of moving the speech to text into the browser, like something like Whisper using WebAssembly in the browser.
I don't want to spoil it, but have you seen the topic of the next presentation?
No.
So let's not talk what you can do in like locally, because the topic of the next presentation, and Chris, I really would love to pass the mic to you in a second, is AI offline. So let's just see what Chris prepared.
Okay.
Please.
The tools for the functionality, is it available only in OpenAPI? Or it's kind of a common thing which can be used by Amazon, for example?
So, sorry again to repeat, but the question is whether the tools are only available in, well, probably I'm using GPT, so in GPT or OpenAI. No, the tools are available in many models. In most of the, let's call them mainline or mainstream ones. And tools can be available in almost any model. However, for a model to use tools efficiently, a model has to be trained on tools or with tools. So any model that was used or was trained to use tools can be used with tools. And those which weren't can be to some extent, but they might just not work as good, let's say. But there is a range of models, so for sure not OpenAI, but anything from Anthropic, most probably, like or Google, or a few others that might or might not be mentioned today. Guys, I can take all of them. Let's just ask, because I will be available for a few hours for you. If there, like, let's take one more, and I don't know which one. So who has the best one? Okay, okay.
No, I was just wondering, the vector you use for the vector search is probably very specific for the model that you use to create it. So you can only compare vectors created with the same model. Is there an approach to make them compatible in a way, like general vector form or so?
It's a great question, and so the question is whether, so the premise is that you can use vectors compare vectors only within the same model, and the question whether there is an approach to generalize that in a way. So the premise, first of all, the premise is correct. Yes, you can, for the most cases, you can only use the vectors from the same models. And not only that, you should probably use the vectors from the same iteration of a model. So if a new version, for example, of Gemini comes, it would most certainly lose the vector space. However, and in here, I'm for sure not an expert, but I remember hearing about the idea that different models or versions of the models can operate on the same vector space. And then, yes, you would be able to use them. However, even if you use those models from GPT-4, I'm using the largest one, available a few months ago. I don't know what's available at the moment, but if I would use like a smaller one and a larger one, they would be in different vector space. So yes, I would have to use only the one model. Okay, guys. Thank you very much.